Dear students, in this video I will explain grade 11 NCERT physics textbook exercise questions and solution. In this video I will be explaining first 5 questions from the chapter 1 units and measurement. Let us see which are the questions. So before we discuss the questions, if you see this channel first time, kindly like and subscribe. So the first question is, the volume of a cube of side 1 centimeter is equal to dash meter cube. So you know that 1 centimeter is equal to 10 to the power minus 2 meter, and also the volume formula is equal to what you can say, the volume of cube of side 1 centimeter is, what is the formula for volume? It is nothing but length into length into length into length. So you will be getting 10 to the power minus 2 into 10 to the power minus 2 into 10 to the power minus 2 meter cube. So you will be, your answer will be 10 to the power minus 6 meter cube. Minus 6 meter cube. So this will be the solution. So the answer for this question, the volume of a cube of side 1 centimeter is equal to 10 to the power minus 6 meter cube. Let us go to next question. The surface area of a solid cylinder of radius 2 centimeter and height 10 centimeter is equal to dash millimeter square. So first you will write the given data. So radius r is equal to 2 centimeter, that is nothing but you can say it is 1 centimeter is equal to 10 millimeter, so 2 centimeter is equal to 20 millimeter, and height h is equal to 10 centimeter. Height h is equal to 10 centimeter, so you know that 10 centimeter is equal to 100 millimeter, right? And the surface area of the cylinder, surface area of cylinder is given by the formula 2 pi r into h. 2 pi r into h. So when you substitute the values, 2 into pi, if I take 22 by 7 into r, I will go with 20 millimeter because they are asking the answer in millimeter square. 20 millimeter into height is equal to 100 millimeter. So once you do this calculation, you will be getting 1.26 into 10 to the power 10 to the power 4 millimeter square. So that is the solution for this. That is the surface area of cylinder of radius 2 centimeter and height 10 centimeter. Alright, so we will go to the question C. A vehicle moving with a speed of 18 km per hour covers how many meters in 1 second? So here this speed is given in kilometer per hour. You know that 1 kilometer is equal to 1000 meter, and 1 hour is equal to how many seconds? It is 60 into 60, that is equal to 3600 seconds, right? So 18 kilometer per hours, you can write 18 multiplied by 1000 divided by 3600. So once you do this calculation, you will be getting, you can cancel this one. So 180, totally you will be getting 180 divided by 36, that is nothing but 5. Okay, so 18 kilometer per hour or 18 kilometer raised to kilometer per hour is equal to 5 meter per second. So the answer is, it covers 5 meter in 1 second. This is the answer, 5 meters in 1 second. Alright. Next question is the relative density is 11.3. The relative density of lead is 11.3. Its density is dash gram centimeter per meter cube or kilogram per meter cube. So you know that the density, the formula for density is equal to relative density, density of the substance divided by density of water. So the density is 11.3 gram per centimeter cube, gram per centimeter cube. You can write it as 11.3 multiplied with 1 gram. You know that 1 gram is equal to 10 to the power minus 3 kilogram, and 1 centimeter is equal to 1 centimeter is equal to 10 to the power minus 2 meter. Yes, once you substitute this one, 11.3 into 10 to the power minus 3 divided by centimeter cube, so 10 to the power minus 2 all cube. So once you solve this, you will be getting answer 11.2 into 10 to the power 3 kilogram per meter cube. Okay, so that's the solution. So here gram you converted into kilogram, because 1 gram is equal to, you know that 1 gram is equal to 10 to the power minus 3 kilogram, and 1 centimeter is equal to 10 to the power minus 2 meter. Okay, so that is a solution, 11.2 into 10 to the power 3 kilogram per meter cube. Alright, we'll go to the question number 2. Fill in the blanks by suitable conversion of units. So here again, 1 kilogram meter square per second square is equal to how many? You know that 1 kilogram is equal to 1000 gram, 1000 gram or 10 to the power 3 gram, and 1 meter is equal to 100 centimeter or 10 to the power 2 centimeter. Alright, so once you substitute this one, 1 kilogram meter square second raised to minus 2 is equal to 1 kilogram is equal to 1000 grams. So 10 to the power 3 multiplied with the centimeter square. Centimeter means 10 to the power 2 whole square, and second raised to minus 2 second, there is no change. Yeah, so 1 kilogram meter square. So your answer will be 10 to the power 3 multiplied with the 10 to the power 4. So your answer is 10 to the power 7 gram centimeter square per second square. So this will be the solution. Alright, now next question is 1 meter is equal to how many light years? You know the light year is the unit of distance. So 1 light year, if you write 1 light year is equal to 9.46 into 10 to the power 15 meter, 9.46 into 10 to the 15 meter. So from here you can understand 1 meter is equal to 1 by 9.46 into 10 to the power 15 light year. So if you do this calculation, you will be getting 1.053 into 10 to the power minus 16 light year. So one important thing is you have to understand that light year is the unit of is the unit of distance. So this is the conversion, light year, how you will convert into meter. Next is 3 meter per second square is equal to how many kilometer per hour square? So meter per second square is the unit of acceleration. So that is I don't think that it's a difficult question. So you can just convert 1 meter is equal to, first you can say 1 meter is equal to how many so 1 meter is equal to 1 by 1000 of kilometer, or 10 to the power minus 3 10 to the power minus 3 kilometer. And 1 hour, 1 second is equal to 1 by 3600 of an hour. Okay, so 1 by 3600 of an hour. So when you do this substitution, you are getting 3 meter per second square is equals 3 meter plus 3 multiplied with the 10 to the power minus 3 kilometer multiplied with 1 by 3600 hour, all to the power minus 2. Once you do the calculation, you will get 3 into 10 to the power 3 minus 3 multiplied with 3600 into 3600 kilometer hour raised to minus 2. So your answer will be around 3.88 into 10 to the power 4 kilometer per hour square. So this is the solution, 3.88 into 10 to the power 4. So that's how we will convert meter per second square into kilometer per hour square. Alright, we'll go to next question. G. G, the gravitational constant, its value is given as 6.67 into 10 to the power minus 11 Newton meter square per kilogram square is equal to how many centimeter cube per second square per gram raised to minus 1. Alright, so you know that Newton is the unit of force, so it will be you can write it as 6.67 into 10 to the power minus 11. Newton means kilogram meter per second square. So because force is equal to mass into acceleration. Alright, so kilogram meter per second square into meter square kg raised to minus 2 you get. So once you solve this, you will be getting 6.67 into 10 to the power minus 11, and here 1 kg is there, 1 kg, here also 1 kg, so it will be cancelled, so you will be getting and here 1 meter, here 1 meter, so we will be getting meter cube, and 1 kilogram and 1 kilogram, it will be cancelled here, second raised to minus 2 and kg raised to minus 1. So once you do completely, you transform into centimeter and gram, you are getting 6.67 into 10 to the power minus 11 into, you know that 1 meter is equal to 10 to the power 2 centimeter, so you will get meter cube. So meter cube you can write it as 10 square or 100 centimeter all cube into second raised to minus 2 into 1 kilogram is nothing but 1000 gram raised to minus 1. So once you do this calculation, you will get 6.67 into 10 to the power minus 8, 6.61 into 10 to the power minus 8 centimeter cube, second raised to minus 2, gram raised to minus 1. So this is the answer you are getting when you do the, when you convert gram G, 6.61 into 10 to the power minus 11 Newton meter square per kilogram square into centimeter cube, second raised to minus 2 per gram raised to minus 1. Alright, we will go to the next question. Is question number 3. A calorie is a unit of heat engine in transit, and it equals 4 joule. Joule is as a unit of energy, where 1 joule is equal to 1 kilogram meter square second raised to minus 2. Suppose we employ a system of units in which the unit of mass equals alpha kg, the unit of length equals beta meter, and the unit of time is gamma second. Show that a calorie has a magnitude of 4.2 alpha raised to minus 1 beta raised to minus 2 gamma square in terms of the new unit. Alright, so here we have a new system of unit. The unit of mass equals alpha kg. What is the unit of mass? It is alpha kg. So 1 kg, you can write it as 1 kg is equal to 1 by alpha of new unit of mass, new unit of mass, and 1 meter, you can write it as 1 meter is equal to the unit of length is beta meter. So 1 meter is equal to 1 by beta, new unit of length, new unit of length, and 1 second is equal to gamma second, it is given. So 1 second is equal to 1 by gamma, new unit of time, new unit of time. Alright, so you know that 1 calorie is equals 1 calorie is equal 4.2 joule, where 1 joule is equal to 1 kilogram. So instead of 4.1 calorie is equal to 4.2 joule. So 4.2 joule, or we can write 4.2 kilogram meter square second raised to minus 2. So substitute these values. 1 kilogram is equal to 1 by alpha. So you will get 4.2 kilogram. You will write 1 by alpha, and meter square you will write 1 by beta whole square, and second you will write 1 by gamma all raised to minus 2. Once you do like this, you will get 4.2 alpha raised to minus 1 beta raised to minus 2 gamma square. So that is the new system of unit. Alright, I think you understand this. 1 kilogram, because we have new unit of mass alpha kg, so we are taking 1 kg as 1 by alpha, new unit of mass, and 1 meter is the 1 meter equal to 1 by beta, new unit of length. 1 second is 1 by gamma, new unit of time. Alright, when you do the substitution, we are getting the answer like this. Let us go to question number 4. Explain this statement clearly. To call a dimensionless quantity large or small is meaningless without specifying standard for comparison. In view of this, reframe the following statement wherever necessary. The atoms are very small objects. So here atoms are very small objects, you can say, but if you say atoms are very small object, we cannot see with your naked eye, or you can say it is smaller than the tip of a pin, or the yeah, actually this statement is true. The atoms are very small object, or you can say you cannot see um, without the microscope or any device, so that you can enlarge the objects. So this one, atoms are very small objects. You can say the size of the atom, size of the atoms are smaller than the size of the molecule. Alright, we'll go to the next one. A jet plane moves with great speed. A jet plane moves with great speed. So how much speed they are moving, we don't have any idea. So you can write a jet plane moves with greater speed compared to jet plane moves with greater speed compared to a bus like that. You can reframe the sentence. The mass of Jupiter is very large, but how much it is large? So you can write here, the mass of Jupiter is very large compared to um, Mercury. The mass of Jupiter is very large compared to that of Mercury. Like this we can reframe the sentence. Alright. The air inside the room contains a large number of molecules. So the air inside this room contains a large number of molecules than outside. Of course you can say like this, the air inside this room contains a large number of molecules compared to outside. So this is, the air inside this room contains a large number of molecules compared to outside. Like this we can write it. Okay. A proton is much more massive than an electron. You can say it's a true statement. If you compare the mass of the proton and electron, you know the mass of the proton is around 2000 times more than the mass of the electron. So this is a true statement. No need to reframe the sentence. The speed of sound is much smaller than the speed of light. Of course, the speed of the sound in air is considered as speed of sound is it varies from medium to medium. Okay, but in air, speed of sound in air is around 330 to 345 meter per second. But the speed of light is 3 into 10 to the power 8 meter per second. So you know that the speed of sound is much smaller than the speed of light. That's again a true statement. So no need of modification. Now we will go to the last question number 5. A new unit of length is chosen such that the speed of light in vacuum is unity. So you take the speed of light in vacuum. You know that it is 3 into 10 to the power 8 meter per second. That speed, take that letter as v. Okay, so the speed of light in vacuum, 3 into take this letter as that unit. Vacuum is unity. What is the distance between the sun and earth in terms of the new unit of light? Takes 8 minutes and 20 seconds. Okay, so time you have to consider, time is equal to 8 minute 20 second. Time is 8 minutes and 20 seconds. So this is a combination of minute and seconds. So you know that 1 minute is equal to 60 seconds. So We can write it as 8 minutes into 20 seconds is 8 multiplied with the 60 plus 20. So you will get 8 into 60 is 480 plus 20, that is equal to 500 seconds. And this is the total time, 500 seconds, and the speed is v. The v is nothing but 3 into 10 to the power 8 meter per second. So what is the distance? Distance is equal to, you know that what is the speed formula? Speed is equal to, speed equals the distance by time. Distance by time. So distance is equal to distance. You can write it as distance is equals speed into time. Speed into time. So you will get speed is v, distance equal to speed into time, v into t. So you will get v into time is equal to 500. So the answer is v is equal to answer is d is equal to 500 v. So this is the this is the distance between sun and earth in terms of the new unit of light. Okay, so far we discussed these 5 questions. So if you like this video, kindly like it and subscribe this channel so that you will get the new notification and also the solution for all NCERT textbook physics chapters. Thank you.